Okay, we're going to start with solving by factoring today. See how this looks. I think that's good. And I need to get this out of the way. Oopsie. All right, so the first thing that we're going to talk about when we solve by factoring is we need to make sure that the equation is in standard form or that it's equal to 0. So if we take a look at this first equation here, we have an equal sign, but then we have a negative 26 to the right. So the first thing we have to do is add 26 to the other side. So if we added 26 to the left and the right side, it would make the right side cancel out and give you a 0. So on the left side, you have x squared plus 15x plus 26 is equal to 0 now. And then once it's in standard form like that, where the x squared and the x in the middle and the number is on the same side, and then there's an equal 0 on the other side, then we can solve by factoring. So we learned that last chapter. So we're going to find my multiples of 26 on the side here. And we're going to see which ones add to give me 15. So we have 1 times 26, 2 times 13, 13 times 2, 26 times 1. I think those are all of my factors of 26. Do any of those add to give me 15? Yeah, there's a couple. There's this one in the middle, or the next one at, so the 2 in the middle, I should say. So either one you can use when we factor the polynomial. So when we factor that, we can use the first one. We get x plus 2, x plus 13. And then we keep the equal 0 there. And then once both of these are factored, now we can actually set each binomial equal to 0 without the parentheses and solve. So if we set the x plus 2 equal to 0, because it's one of my factors, and the x plus 13 equal to 0, and solve, we'll get 2 different answers. And the number of answers is always going to be the biggest degree that you see, or the biggest exponent you see. That's how many answers you should always have from here on out for the rest of your math career. If it's an x to the first, you should only have 1 answer. If it's an x squared, you should have 2. If you have an x to the third, you should have 3. So if we take a look at this, we should have 2 answers since it's x to the second power. That's the biggest power I see. So if we subtract 2 from both sides, we learned this back in first semester, subtract 13, we're going to get 2 answers, and my 2 answers are x equals negative 2 and x equals negative 13. And if you take either one of those and plug it into the original function, so let's say we took this negative 2, and we plugged it in right there for x, and right there for x, it should give us the left side always equaling the right side. That's called a solution to an equation. It's what makes the equation true. So if we were to plug in the negative 2 and the negative 2 again, that should make the left side equal negative 26. So we'll see here. This would be 4. This would be plus negative 30. And I think in the end, when you plug that in your calculator, 4 plus negative 30, you get negative 26 is equal to negative 26. So that's a way to check your work, just like we've checked it in the past. So the rule of thumb here is to find x only when the directions tells you to solve. So when it says to solve, that's where we're going to be finding x every single time. If it doesn't tell you to solve and it just tells you to factor, you just need to set it up into 2 different binomials. The next page, I think that this was supposed to go on the other one. The top here says make sure that the equation is in standard form. So that just means that everything is on one side. We talked about that earlier. And then the right side would be equal 0. Or you can move everything to the right side and make the left side equal 0 before you start to factor. Now, the directions here say to solve each polynomial. So if we solve these polynomials, that means that we're going to factor them first, and then we're going to make each factor equal to 0. If we take a look at number 1 and 2, they both are already factored for us. So those are much faster than the normal ones because we don't have to worry about trying to figure out the factors. So if we were to take a look at the first one here, we have a 7x plus 14. We make that equal to 0. And a 7x plus 5. We make that equal to 0. We subtract the 14. And we subtract the 5. So now we have 7x equals negative 14, 7x equal negative 5, and we want to solve for x. That means get x by itself. So if we solve for x, we divide by 7 for both of these. So then we get x equals negative 2, and x equals negative 5 over 7. And those would be my two answers. And it's okay to get a fraction, just like it was okay to get a fraction when we were solving before. And if you plug in either one of these numbers into the original, into right here for x, into right here for x, so this place and this place, if you plug them in, it should make the equation equal to 0. So I'll give you an example. If we plugged in negative 2, that would be 7 times negative 2 plus 14 in one of the parentheses. The other parenthesis is 7 times negative 2 plus 5 in the other parenthesis. So that'd be negative 14 plus 14. And this would be negative 14 plus 5. So in the end, this would be 0 times negative 9, which would be 0, because 0 times anything is 0. So in the end, it does match up to this side. So it makes the equation true. The next one's already factored as well. So if we set both those factors equal to 0 and solve, it's an easy one for us because it's already done. So both binomials we just set equal to 0. And then we solve by doing a two-step equation always. So we'd have to add the 5 and subtract the 6 by inverse operations. And then we divide by 4 in the end. And that will give us 5/4. And, oh, that should have been an A, shouldn't have been. Oopsie. And that will give us 3/2, I believe, when you simplify 6 over 4. It's okay to get two fractions. And these two fractions, if you plug them into either one of those equations up above with your calculator, you're going to get 0 equals 0 in the end. So you can either plug in 5/4 into both A's or negative 3/2 into both A's. And in the end, you'd get the left side to equal 0. So that's how you know you did it correctly. If we continue to move on, number 3, I'm going to allow you guys to press pause. Why don't you guys try it and see if you get the same two fractions that I got. All right, welcome back. So this is what you should have done. You should have added the 11, subtracted the 16 when you made them both equal to 0. You would have divided by 3. Got 11/3 and negative 16/3. So those would have been your two answers if you would have done this on your own. So number 4 is one where it's not already factored for you. You're going to have to factor it yourself. So the first step in all factoring that you learned last semester was to try to pull out a greatest common factor. So if you take a look at this, is there a greatest common factor you can pull out? Your answer to yourself should be yes. You should be able to pull out an x from both of these terms. So if you pull out an x, you get x times x minus 4. And then you set both of these factors equal to 0. So we have this x we can make equal to 0. This x minus 4 is equal to 0. And we would add the 4 to the other side for the right side. The left side's already solved for, so I don't have to worry about it. It's already got x by itself. So in the end, we have two answers. One is x equals 0. The other one is x equals 4. And that's your answer. All right, so now if we go on to number 5, I think number 5 is a regular factoring one where we're going to have to, oh, here's number 5. Wasn't it 4? Yeah. Oh, 5. There we go. is another factoring one that's similar to number 4. I'm going to give you guys a second to see if you can do this one on your own. Press pause, and then we'll come back and see if you did the same thing that I did. All right, welcome back. If you would have factored this, you could have pulled out a GCF, pulling out an x from both terms. And then from there, if you set both equations equal to 0 and solved, you would have got x equals 0 and x minus 8 equals 0. So then we have to add 8, and we get x equals 0 and x equals 8. And those would be my two answers, just like the last one. And then number 6 is a little bit stronger even, because this one is where you have to factor the trinomial. So if we factor this trinomial, we'd find my multiples of 144 on the right side here. So if we write them all down, I think we got a bunch. 144 divided, does it divide by 3? I'm using my calculator if you're wondering what I'm doing here. 144, I think it divides by 4 too. Yep. 4 times 36. 144 divided by 6 times 24. 144, does it divide by 8? Yep. Move this up so it's out of the way of that little thing in the corner. 144 divided by 12. I think those are all of them. So now we just check to see if any of those add to give me 24. Well, I see one that adds to give me 24, but it adds to give me a positive 24. I see the middle as a negative. So if you recall from factoring, when you see a negative in the middle, but a positive on the last term on your C value, that means both of these should be negative then. So if we make them both negative, it would still multiply to give me a positive 144. But now they're going to add to give me a negative number. So when I add them together, I believe the last one is the one that gives us negative 24. So we would get a minus 12 times a minus 12. And then we set each one equal to 0, and we'd solve. So now if we get a minus 12 equals 0, a minus 12 equals 0, we're going to get the same answer twice. We get a equals 12, right? So we can circle it if you get the same answer twice. You might have it written like this as well, only one time since it's the same answer. Either one works out. So we both have an a, and then an equals 12. So you can write it once since it's the same answer twice, or you can write it 2 different times. We won't take off points if you write it twice. Then the next page, I think gets a little bit tougher with some of these. So this first one is a little bit tougher because you have to remember to try to factor by pulling out a GCF, or a greatest common factor. So the first thing you have to do is divide by a number that goes in all three. And they all have a 2 that can be pulled out from all three. So if we have a 2 that can be pulled out from all three, that goes on the outside. On the inside, I'm left with an x squared minus 5x plus 4. And then we try to factor that. So whatever's left in the parentheses. So we write down all my multiples of 4 again, and we see which numbers would add to give me negative 5. So I know 1 and 4, 2 and 2, and 4 and 1 are all my possibilities. I see that the middle has a negative again, so that means that I'm going to have to write 2 negatives out here, because I would still multiply to give me a positive 4, but add to give me what I'm looking for in the middle, which is a negative 4. So do any of these add to give me negative 5 is the question? And the answer is yes, there's 2 of them, this one and this one. So now if I do this correctly, I have a minus 1 and a minus 4. Or you can write it the opposite direction, x minus 4 and x minus 1. It doesn't matter the order. So now you have 3 things. So you have this 2 on the outside that is a factor. You have this x minus 1 is a factor, and the x minus 4. Well, I know from the beginning, I said that whatever your biggest degree is how many zeros you should have. So it's an x squared. So we shouldn't have 3 zeros. So which one are we going to throw out? Well, that 2 equaling 0 doesn't have an x attached to it. There's no x in that equation. So that's the one that I would always get rid of. And 2 does not equal 0 mathematically. It doesn't even make sense. So that one you get rid of, the GCF without an x. And the other two, when you solve, you'll get good answers. That makes sense. So now you get x equals 1 or x equals 4. So that's my answer. Yeah. And then if you plugged in either one of those, you'll get 0 equals 0 in the end, once again. So that's how you can check your work, is plug it in and see if it makes the equation true or not. This next one is not solved for. It doesn't have an equal 0. So I know I have to add this 14x to the other side. So if I add this 14x to the other side, I would get x squared plus 14x plus 40 now. Now it's written in standard form, where the x squared's first, the x is second, and your constant's third. And now I can try to factor that. First question always is, can I pull out a greatest common factor? The answer is no for that. So the next question is, are there any multiples of 40 that add to give me 14? So if I write down my multiples of 40, I think those are all of them. Do any of those add to give me 14? Is the question. And I have that one, and I have that one. So now we're going to take a look to see if either one of those adds, or we're going to take a look at what our final answers are going to be if we set both of those up as our binomials. So we have an x plus 4 and an x plus 10. Make them both equal to 0. And then we solve. So in the end, we'd get negative 4 is one of my answers, and negative 10 is my other answer. And if you plug in either one of those, you're going to get 0 equals 0 up top when you plug it into the original. All right. This next one's not solved for either. So that means that we're going to add that 28 over to the other side. And we're going to get m squared minus 11m plus 28 equals 0. We would find my multiples of 28 since we can't pull out a greatest common factor. So I think we got a few of them here. 1 times 28, 2 times 14, 4 times 7. So I think these are the 6 that we got. Of all those, do any of them add to give me negative 11? Well, since the middle is negative and the last number is positive, I know these both have to be negative numbers. So now we can really take a look to see if any of these add to give me a negative 11. So now I believe this one that I'm going to circle, the negative 4 and 7, and the negative 7, 4. It doesn't matter which order you write it in because you'll get the same answer in the end. So if you pick one of those two, you'll be in business. So it's m minus 4, m minus 7. Make them both equal to 0. Then make each one equal to 0 and solve like we did on the other side and for all these so far. So in the end, we get m equals 4 when you add the 4 over. And then m equals 7 when we add the 7 over. So that'd be my two answers. And the last one is one that's not equal to 0 either. It's not in standard form yet. So we need to make sure that we subtract that 6 over to the other side. So when we subtract the 6 over, now it will be equal to 0. So now we have 2x squared plus 21x plus 19 equals 0. So I'm trying to pull out a GCF first. That's always my first step with this, and I don't believe that I can. So now I know that I'm definitely going to set up, like we did with guess and check during the factoring unit, a 2x and a 1x, because that's the only thing that would multiply to give me 2x squared to begin with. And then I have to set up my multiples of 19. I think that we got lucky here because there's only 2 of them. So we have 19 times 1 and 1 times 19. So I'm going to give the first one a try and see if it gives us the original equation or not when we plug it in. So if we do plus 19 plus 1, I'm going to multiply this out to see if it gets us back to the original. So we multiply the first terms by each other, or double distribute, and then we multiply the outermost terms by each other. And then these ones that are right next to each other, so the 19 times the x, and the 19 times the 1. So in the end, we get 2x squared plus 21x plus 19. So I think that's what we were looking for. So this is the winner. So we're just going to solve for those two. Oopsie. We're going to solve for those two binomials and see what we get. So this one would be 2x equals negative 19 divided by 2. This one we just got to subtract 1 from. So now we get x equals negative 19 over 2 and x equals negative 1. That's a 9, sorry about that.